I'd like to show you how to work through a homework problem from the textbook in chapter 1. So let's get started, and I'm going to give you some advice moving forward in the class as well. So you're going to have to put up with that, but I would like to sort of show you how I worked through a problem solution and documented my work. So this is going to be problem 112 from the textbook. So let's look at the problem statement and then go from there. Oh, some friendly advice first, not the problem statement yet. You're going to find that most of the problems get out of the textbook in chapter 1 are very, very easy. So you can see Snoopy giving you a little advice. The advice I'd like to give you is that I'd like you to resist the temptation to believe that all the problems in ME 2134 thermodynamics are going to be this easy. I can assure you they are not going to be this easy. They get a little harder in chapter 2, but in chapter 3, I would say these homework problems get more difficult. They get harder and harder as we go along. Chapter 4, I'd make the same remark, even harder than chapter 3, et cetera, et cetera. So I do want to suggest that you recognize that these early on problems you're going to sail through, but don't get a false sense of security that you're going to just sail through this class without a lot of hard work. All right, so that was my pep talk a little bit. Let's look at the problem statement of problem 112. At a certain elevation, the pilot of a balloon has a mass of 120, it says lb, that's pounds mass, and a weight of 119 pounds force. What is the local acceleration of gravity in feet per second at that elevation? Reasonable question. If the balloon drifts to a new elevation where g, acceleration due to gravity, is 32.05 feet per second squared, what is her weight in pounds force and mass in pounds mass? So I'm hoping, you say, gosh, we sort of did this kind of stuff in high school. So this is going to be incredibly easy. Let me show you how I solve this problem. The first thing I do is start with a sketch, and you should also start with a sketch on your pencil and paper homework solution. Now, your sketch does not need to be a work of art like this is, because I wanted to present a nice professional looking PowerPoint slide. Your sketches in this class do not need to be professional looking at all. They just need to be good enough so that you can understand what you did when you go back and look at your work, and so that others, particularly those grading your work, evaluating your work, will be able to understand what you're doing as well. Now, another thing that I really want to point out for this particular homework problem is that it says the pilot has a mass of 120 lb. And you see that in my sketch, I have immediately switched that over to lbm. The textbook uses lb as the unit for mass. And so recognize the textbook lb is the same as lbm pounds mass. Okay, let's look at my sketch. So that's an important point. The other point is you recognize that this problem is in the English system of units. It is a tougher system of units to deal with than SI. I totally agree. But you're going to need to get good at dealing in both systems of units to ensure that you're going to be able to perform well on your quizzes and tests, because instructors typically give a mix of problems on quizzes and tests in the exam. They give a mix of English system problems and SI system problems. Okay, back to the sketch. I've shown sort of, here's elevation 1. I've written down my given information, drawn a little sketch of a balloon, and I'm showing some elevation above ground level. And I'm saying what we're looking for, G equals question mark. Another thing that a pretty basic thing that's common sense 101. You don't need to read your textbook for this. is that the mass of the pilot at state 1 exactly equals the mass of the pilot at state 2. Let's say the person uh, isn't eating anything and stuff like that. The person's mass is constant. It's a property of the person. It's a physical property of the person. That's the person's mass. So the pilot's mass doesn't change. And so actually you can get a third of the way through the problem by simply writing down M1 equals M2 equals 120 pounds mass, LBM, right? So that's a no-brainer just about. I've sketched elevation number 2. I've written down my given information on my sketch. You see that? I'm saying, well, what do I want to find? Weight number 2, question mark. And both of these states, state 1, elevation 1, and state 2, elevation 2, I'm showing relative to ground level just to kind of use some common sense, okay? And also, you know, in my sketch, I said, we're going to use the basic fundamental weight equals mass times the acceleration due to the gravity. That one you've got from high school. So this ought to sail along pretty fast, except for some English system details. English system details has to do with conversions of units. And so immediately I want to point out, if you haven't done so yet, you need to find in your book this one page that looks like this, might be a little different color, might be a blue color, but it's a one-page conversion factors. You can see it's a bunch of things, some units equals some other units with numbers associated with it. You need to find this table in your textbook and figure out how to save as, let's say, to a PDF file, or at least print a paper copy of that one page. At least do that. If you aren't able to do that, if you aren't able to find this one page in your textbook, go to my J's Toolbox Canvas site. On my Canvas site, if you click on the Files folder, the Tutoring 2134, you're going to find all my different file folders. And if you click on the Resources folder, you can download this PDF file that I call Moran and Shapiro Conversion Factors. You just download that and you can possess it and print it out, and you'll be in great shape. You must do this. All right, back to our homework problem. Let's see. Let's first figure out the acceleration due to gravity at state 1, or in other words, elevation 1. Okay. Well, we'll write down here's a little bit of a sketch that you would have shown up higher, of course, starting in your solution, your handwritten solution. You're going to write down the fundamental. W1 equals M1 times G1. So all that's associated at state 1. And you can say, well, I'm going to solve for G. I got to solve for G. So you write that down. G is equal to W over M. That's not extremely difficult. You might write, you see that I've checked off things I know. I've put a check next to, and I've written down numerically, W1 is 119 pounds force, M1 is 120 pounds mass. And it's tempting to say, well, G1 is just 119 over 120. That's not the right approach, because you're looking for G in terms acceleration in terms of feet per second squared in the English system of units. This is where that conversions factor page really comes in handy. You're going to shop through there and you're going to find under the force little section, you're going to see 1 pound force equals 32.174 pounds mass. So in my world, I call that LBM, times feet per second squared. Okay. I'm going to give you a commercial for the way I deal with units here in a second, but recognize that you see this with your eyes. Do you see that if you can divide one side by the other to get simply unity without units? 1 is equal to unity. And for this, I'm planning ahead and I'm looking and I say, well, I'm just going to put in my numerator, I'm going to put 32.174 pounds mass feet per second squared. Denominator, 1 pound force. That's the conversion, and that's unity. So remember, I can multiply any mathematical expression by 1 or unity and preserve that mathematical expression. That's going to be critical for your success in thermodynamics class and beyond in the rest of your mechanical engineering classes. So let's do the math. with our units. So W over M, W, 119 pounds force, divided by M, 120 pounds mass. I'm going to put in unity, 32.174 pounds mass feet per second squared, divided by 1 pound force. And now visually, I can strike out units along with doing the calculations. Pounds force cancel, pounds mass cancel, and what I'm left with is feet per second squared. So I go to my calculator, I do my calculator work, and I've got my result to get 2/3 of the way through this homework problem. G1 is 31.906 feet per second squared. Now, and you see, what have I done? I've included units in my answer. I have circled my answer, and in my world, as a result of my engineering practice, once I graduated with my advanced degree, I will write out in a sentence, the local acceleration due to gravity at state 1 is 31.906 feet per second squared. So I take the time to write that out in a sentence. You might train yourself to do that because of time constraints. You might not do that, but at least you've got G1 is clearly circled with units and a number. Okay, we're coming down the home stretch. Figure out the pilot's weight at state 2 or elevation 2. We'll write down our fundamental. W2 equals M2 times G2. Okay, I've got both of those. M2, that's M1, 120 pounds mass. G, given, 32.05 feet per second squared. I've checked those off. Now, the trouble is we can't just go to the calculator because W2 needs to have units of pounds force. If we just went to the calculator, we'd have pounds mass feet per second squared, and that's useless to us as engineers. We're going to go right back to that same conversion factors page. We're going to do the same unity approach, except let's plan ahead. What are we, so we can visually see in our solution, W2 is mg, okay? I'm praying for pounds force. So do you see that it kind of makes sense to write out unity is 1 pound force divided by 32.174 pounds mass feet per second squared. I'm kind of planning ahead to do that. And so I'll write out my fundamental, W equals mg, 120 pounds mass, 32.05 given feet per second squared. And here's my unity conversion. And so it's just so easy. Take the time to do this because it's so easy to strike out units to see that you're correctly ending up with pounds force. I'll do the math on the calculator, 119.5 pounds force. And like I say, in my discipline, I'm going to write out both of the results at state 2. The pilot's mass at state 2 is the same as state 1, 120 pounds. That's kind of helping my grader see that I know what I'm doing. And the pilot's weight at state 2 is 119.5 pounds force. Also, recognize that I'm putting in a reasonable amount of significant figures. I'm not writing out 8 significant figures for the person's weight, right? So instead of just writing out all those significant figures, I'm using some common engineering sense to say, well, I'm just going to report 4 significant figures, 119.5 pounds force. What do you think? It went extraordinarily quickly. You would have been able to solve this problem in time quicker than I took in explaining it. Now, you may have watched me in the solution that I presented to you, what I did. I follow a basic problem-solving recipe that my professors taught me to do. Now, this might not be the problem-solving recipe. Your instructor may be guiding you slightly differently. That's okay. You need to develop your own basic problem-solving recipe that works for you. But please recognize, here's what I do. My professors, and I didn't start off this well. I didn't start off with this recipe at all. My work was sloppy. My sketches were horrible. I got better and better at it because when I was a student, our instructors, they graded our homework. And so we got some good feedback on how well or poorly we were doing on our homework. We didn't just get a homework grade. We got a good bit of written feedback. So here's what I learned. I read the problem in words first. I always start with a sketch. I plan my work before going to the calculator, before going to conversion factors. I sort of jot down, what am I going to do? What are my fundamentals? And then I work through the solution. I hope you saw that I worked down the page. I wrote down my fundamentals, not just numbers. I tried my best to explain my work. I kept units throughout my engineering problem, and I try to explain my work in words. And so if you would like to get a little, and I'm trying to see how long this takes. My memory is it's about 25 to 30 minutes where I do more talking about this recipe. I give some example problems of working through this recipe. If you go to my YouTube channel, look at homework solutions, the very top video is going to be Problem Solving 01. And I encourage you to have a look when you've got a little time early in the semester. Just browse through this video. It might help you as you develop your own style of problem solving. Units. It could be that you picked up this units discipline just in this video alone. If you need to get more of a memory refresher about working with units and other types of units, rather than just English system, mass, and force, go to my Thermodynamics Fundamentals playlist and click and find Working with Units. And that's 32 minutes. And again, you can browse, you're welcome to browse through that. I give some examples, and I talk a lot about that unity thing that has saved my bacon as a student and as a practicing engineer over and over and over again. So let's recap this homework problem. We start with a sketch. Any homework problem, start with a sketch, even if it's a matter of kind of quickly redrawing a sketch that might be given to you in the problem statement. Get that down on with pencil and paper on your solution. Plan your work. Start with the fundamentals, not just formulas that might be given to you. Certainly don't copy formulas from other people or other example problems. That is a loser, because that you're not preparing yourself to do well on quizzes and tests and the exam. And that's what I and we want you to do. We want you to perform well on all those so you get a good grade in this class. Another key to success is checking your units as you go along. Work with units throughout your solution, and of course, include units in your final result. One thing that I would criticize the textbook about is, do you remember it said, what is the pilot's weight in pounds force? That is not indicative of the engineering world of practice. Your supervisor doesn't say, I need your answer in pounds force. You're just expected to know that you need to provide a weight answer in pounds force. And so always, always include units in your final result. And don't be a smart aleck and saying, well, the textbook said provide the result in pounds force, so I just wrote down 120.5. That's not good practice. Okay. So strong recommendation, and hopefully a learning from this particular homework problem is, from when you see LB in the textbook, write down LBM in your work. That's a mass, because that's dramatically different than a force, LBF, in the English system of units. So strong recommendation to adopt that habit. Don't write LB in your solutions. And you're going to see throughout the example problems, homework problem solutions that I provide, you won't see me write LB. I'm always writing LBM, recognizing that the book is using a little bit of a shortcut. So that's it. That's my offering for a homework solution out of Chapter 1. I do hope you said, gosh, that looks so easy. Want to recommend that don't develop a false sense of security that you think we're lying to you. We're trying to get you all hyped up and think it's going to be hard, it's going to be easy. I can assure you that it's going to require a good bit of hard work on your part to succeed well in this class and beyond in your future mechanical engineering classes and in engineering practice. So good luck, and hope to see you with looking at some homework problems that I share with you for Chapter 2.